Hey guys, and welcome back. So in this video, we are going to do the next piece to what we started yesterday. So yesterday we did all equations where we had the slope and we had a point. And we wrote our equations into point-slope form and then simplified it into slope-intercept form. In this video, and in tomorrow's lesson, we will be given 2 points, but not a slope. So in order to write the equation of a line, you need a couple of things. So to write a linear equation, you need one of these options. You either need a point on the line and the slope, you need the slope and the y-intercept, or you need 2 or more points on the line. We've actually written linear equations using all of these options from Unit 1, or at least options 2 and 3, because we were given sequences that were arithmetic, and we've learned that arithmetic sequences are linear. So we had a bunch of points on the line, and we just wrote our explicit functions using the starting point. And then yesterday we worked with a point and a slope. So now I'm just going to give you 2 points that are on your line, and we're going to work to find our common difference to then be able to write our equation. So when you look over here, you want to first use your slope formula to find the common difference. And you could also make a table. And I will show you both options. So your slope formula is that m is equal to y2 minus y1 over x2 minus x1. You will then pick a point and then use the point slope formula, which we talked about yesterday, as y equals m times x minus x1 plus y1. So looking at number 7, and again, just like in yesterday's examples, we are going to do odds, leave in point slope, and even simplify. So in number 7, we are going to first, so we have 2 points. So the first thing we're going to do is find our slope. So method 1 is to use your slope formula. So I'm going to label this out x1, y1, x2, y2. Remember that every coordinate pair is made up of an x and a y. So my slope formula will say that I need to subtract my y's on top. So I'm going to do y2 minus y1, so negative 1 minus 7, over x2, which is 1, minus x1, which is negative 3. And then you just simplify. So negative 1 minus 7 is negative 8. 1 minus negative 3 turns into 1 plus 3, which is 4, to give us a slope of negative 2. Method 2 is to make a table and then look at your change. So here's x, here's y. So I'm just going to put my points into my table. And then I see how it's changing. So from 7 to negative 1, I am minusing 8. From negative 3 to positive 1, I am adding 4. Then I'm just going to do my change in y over my change in x. So my slope will be negative 8 over 4, which, as you can see, is the same as what we did in method 1, to then simplify to be negative 2. So choose whichever method you like the best. I will tell you that if you don't remember the slope formula, then using the slope formula is not the best way to go. If you know that you're bad at remembering formulas, then you might consider using method 2, because you don't have to remember much, except that you always do the change in y over the change in x. So let's actually add that to the top. So it'll always be the change in y over the change in x. And we'll talk about that a lot in class as well. So now that I have my slope, I'm just going to pick a point. Doesn't matter which point you choose, you just pick a point. I'm just going to choose that one. And so I'm going to highlight the point I'm going to use. So I'm going to have an m of negative 2, and a point of -3, 7. And I just plug into my point slope form. So y is equal to my slope times x minus -3 plus 7, which is the same as y equals -2 times x plus 3 plus 7. Since the odds I'm leaving in point slope form, then I am done. If you use the other point, then your point slope form will look slightly different because your points are different. So your numbers your 3 and 7 would be -1 and -1. So it'll be a little bit different, but we'll see when we get to the other side that they would still simplify to be the same. I would accept either answer that you give. If you gave me y equals -2 times x plus 3 plus 7, or if you gave me y is equal to -2 times x minus 1 minus 1, both of those would be accepted on a test or a quiz. So let's do number 9. I prefer to use method 2, so I'm going to just use method 2, which is make a table to find my slope. You are welcome to use the slope formula if you would like. I just find that a lot of students do better with this method. So I'm just going to plug my 2 points into my table, and then I'm going to look at how it changes. So from -1 to -6, I know that I am minusing 5. And from 2 to 4, I'm adding 2. So my slope will be the change in y over the change in x. -5 over 2 is simplified, so I just leave that. I will then pick a point. I'm going to choose a second point just for fun because I did the first point in the last one. So my slope is -5, 2. My point is 4, -6. So my equation will be y is equal to -5 over 2 times x minus 4 minus 6. If you had used the other point, then it would be x minus 2 minus 1. Since it's odd, I'm leaving it in point slope form. You try and do number 11, then come back to check your answers. So upon working out number 11, you should have found that your slope is 1, and thus you would get either the equation y equals 1 times x plus 6 minus 3, or y equals 1 times x plus 4 minus 1. Both of my x's in both points were negative, so the part before it would be x minus -6, which we know is plus, or x minus -4, which we also know is plus. So let's see what happens when we simplify. So looking at number 8, again, we only have 2 points, so we are going to find the slope. So using method 2 again, I'm going to have -6, -7, and then 3, -4. So my change from -7 to -4 is that I am adding 3. And from -6 to 3, I'm actually adding 9. So my slope, I'm going to put it up here for space, is going to be 3 over 9, which is 1/3. Remember, fractions are okay when it comes to slope. Leave them as fractions, improper fractions, proper fractions, doesn't matter, but fractions are okay. It will always be the change in y over the change in x. So even though 9 is bigger than 3, you do want to make sure that you put 3 on top because it is the change in y. Then you pick a point, and I'm actually going to do this with both points, so I'm going to color code this. So my blue goes together. So I'm going to have y equals 1/3 times x plus 6 minus 7, because I would have had minus -6, which changes it to a plus. I'm going to then put this in slope-intercept form. So I'm going to distribute my 1/3 into my parentheses. So I'm going to have y is equal to 1/3 times x plus 1 times 6 is 6, divided by 3 is 2, minus 7. And then I will, you know what? I just wrote that wrong. I distributed to get rid of the parentheses, so I need to not have parentheses in my answer there. And then you combine your 2 and your -7 to then get y is equal to 1/3 x minus 5. Now I'm going to do pink, and my pinks will use the other point. So I'm going to have y is equal to 1/3 times x minus 3 minus 4. Again, I'm going to distribute the 1/3 in. So I'm going to get y is equal to 1/3 x. 1/3, or 1 times -3 is -3, divided by 3 is -1, minus 4. And then combining my like terms, I get that y is equal to 1/3 x minus 5. And as you can see, they both come out to be the same. And that's because every point on the line will fit into our equation. Just like the explicit formula found as any term in the sequence, a point-slope form or a slope-intercept form equation will find us any point on the line. So plugging into point-slope form and simplifying, no matter what point you choose, will always get you the same slope-intercept form. So from here on out, you only have to choose one point. I just wanted to show you that it didn't matter which point you used. So let's do number 10. Once again, I have 2 points that I'm going to find the slope of. So I'm going to make a table, -3, -8, and 2, 7. Looking at my change, -8 to 7 is an increase of 15, and -3 to 2 is an increase of 5. So my slope will equal 15 over 5, which is equal to 3. I should put that over here. So then you pick your point. Doesn't matter which point. I'm going to choose 2, 7 because it's positive. You might always try and pick positives. It does not matter. So y will equal 3 times x minus 2 plus 7. Then distribute because we're putting it in slope-intercept form. So y equals 3x minus 6 plus 7. And then lastly, combining our like terms, y will equal 3x plus 1. You can always check yourself by plugging -3, -8 into your equation to see if it works. So you would kind of go over here and check, and you would say -8 is equal to 3 times -3 plus 1. And you just want to know, is that equal? So then you simplify. 3 times -3 is -9 plus 1, and -8 will be equal to -9 plus 1, which is -8. So you know that you've done it correctly. All right, so you guys try number 12 on your own. So when you make your table and find your slope, you get that you're changing by -5 and 10, which gives you a slope of -1/2. Plugging in either point, it doesn't matter. I chose 6, 2. And so when I distributed, I did -1/2 times x, which is -1/2 x. -1/2 times -6 gave me +3. And then +3 plus 2 gives me the +5 that I got at the end. So it shouldn't matter if you plugged in the point -4, 7 or if you plugged in the point 6, 2. Your final slope-intercept form equation should be y equals -1/2 x plus 5. So tomorrow in class, we will work the rest of the examples on this notes sheet, and I will answer any questions that you have. See you then.